Okay, so welcome to chapter 3. Chapter 3 is a proof heavier chapter, but it's also an algebra heavy chapter when we get to sections 3.3 and 3.4. But I think it's the first chapter where things really start to click and set in with what we're doing. So hopefully you'll feel this way as we kind of move through that the process, the ideas, and the theorems and everything kind of finally start to click. So either way, 3.1. Parallel segment or parallel lines and transversals. This is mostly just a definition section. Shouldn't take us too terribly long to get through on the video, nor should it take us so long in a class to get through. So we've already proved angle and line segment relationships for theorems, and now we're going to do things with two lines and two planes, and then parallel lines in this thing called transversals. So parallel and skew. Parallel lines. They are two lines that are coplanar, and that's the key to them. Two lines that are coplanar that do not intersect. Now skew lines, so you got like LM and JK here. The symbol for it is two vertical lines. That means parallel. Basically, we draw two vertical parallel lines, and then you say the two lines on each side of it. Whenever they have these purple arrows on them, or if it's been copied, it'll be like grayish. Those tell us that these two lines are also parallel. So you can either have the drawing or the notation, or we'll learn throughout the chapter how to prove that two things are parallel. Skew lines, trying to get ahead of myself a minute ago. Skew lines are not coplanar, and they do not intersect. So the big difference between parallel lines and skew lines is that parallel lines are in the same plane. Skew lines are not in the same plane. So, for instance, they've got line L here and line M here, and neither of those are parallel because they're in different planes. A and B are different planes, but more importantly, they're never going to intersect, so that's why we call them skew. Parallel planes, pretty obvious, planes that don't intersect. Okay. We already talked in the last chapter that if two planes intersect, they form a line, so we've already got that covered too. So, first example, name all segments parallel to segment BC. Okay. So here we go. What it kind of helps to do is kind of highlight BC. So here is segment BC. That didn't show up at all, did it, with yellow? Let's try a different color. My highlighter is starting to kind of fade on me. I need to get some new ones. Orange kind of works. So there's BC. Okay, that's segment BC. Now I want everything parallel with it. Now hopefully it's kind of obvious looking at it that if you looked at the front plane here, that DA and BC are parallel. And then if you looked at the side plane, that BC and FG are parallel. Those two. But there's also one more segment that's parallel to CB. And it's kind of hard to tell because it's not in a plane that's drawn. If I cut through this, like imagine it's like a block. If you cut through this at a diagonal, okay, what ends up happening is you get a new plane right here through the diagonal of this. So EH in the back corner here is also parallel to FG and AD and CB. All four of those guys, not at one time, are parallel to each other, but they're all parallel at different points in the drawing. Example B, name a segment skew to EH. Okay, so I gotta go back to the drawing then for that. So EH is this guy over here in the back. Now I know that all these vertical ones, if you want to think of it going up this way, those are all parallel to it. So it can't be any of those other three, DA, BC, or FG. And then AH and HG intersect, and EF and ED intersect because they meet at E and H. So our skew segments are really any segments here that go opposite directions. So DC is a skew one. Not EF. FC is a skew one. Okay. BG is a skew one. And then AB is a skew one. Those are our four skew segments. I made them lines, but those are the four skew segments. And then, last but not least, name a plane. I'm sorry, here, the same thing here in the guided practice that what I talked about over here in this drawing. That don't forget that EH and CB are parallel, not skew. In this case, we're in BC and FE are parallel, not skew, because that's diagonal. And that's a much better drawing than I made, so I threw it in there to make it pretty. Okay, now plane parallel to ABG. ABG is the base. Okay. ABG is the base, ABG, those 3 points. So the only one that be parallel is the one on top. So basically pick any 3 points out of D, E, F, and C. So DEC, DCF, FEC, whatever you want to use, any of those 3 points will work. All right, now transversal. A transversal is just a line that crosses another 2 couple lines. Okay, so if you have two coplanar lines already going through, and then you run another line across them, that is called the transversal, and it's parallel to it. So a line that intersects 2 or more coplanar lines at different points is called the transversal. Be prepared to define that on your test and on the semester exam. Okay, so in the drawing here, we've got that T is the transversal, and it crosses through the lines Q and R. And the first thing it does is it creates some angles for us. The angles between the 2 lines that the transversal crosses are called interior angles. The ones outside of the ones out, they're called exterior angles. Okay, so when we say interior or exterior, those interior and exterior are with reference to the 2 lines that cross the transversal. So this is the last bit of the section, really. There's just a bunch of different types of angle types. So the first type of angles are the interior angles that lie in between the transversals, between the 2 lines that cross the transversal, so Q and R. And then exterior angles that lie outside. So 1, 2, 8, and 7 are our exterior, 4, 3, 5, and 6 are our interior. Now, the next type of angle pair are called consecutive interior angles. And the way they work is they're on the inside angles because they're interior, but they're all on the same side of the transversal. So if I look at these here, here's the transversal. Okay, we have the interior section here. So 4 and 5 are a pair of consecutive interior angles. And the reason they call them consecutive is there's another one next to it. And 3 and 6 are our pair of consecutive interior angles. So 3, 4, 5, and 6 aren't all a pair. It's 3 and 6 and 4 and 5 that correspond. All right, next definition type, alternate interior angles. Again, alternate and interior. So interior means we're on the interior side. Alternate it says non-adjacent, but what that means is they're on opposite sides inside the interiors. So here we go, alternate interior. So I have, again, my transversal that's cutting through here. Okay. And here are my interior angles, 3, 4, 5, and 6 again. Now I went alternate interior, and I don't want them to be next to each other because they can't be adjacent. So 4 and 6 are a pair of alternate interior angles. Again, opposite sides inside. And then the other pair of angle types is 5 and 3 that are alternate interior angles. Okay. So 4 and 6 are a pair, 3 and 5 are the other pair. Okay. Alternate exterior, same thing, but this time instead of being in the interior, they're in the exterior groups. So non-adjacent exterior angles that lie on opposite sides of the transversal. So okay, we're talking outside angles this time, so we get to ignore this business. Okay. So if I draw in my transversal T, okay, we get 1, which is an exterior angle. Now I need to be on the opposite side of the transversal, outside, and not adjacent to it, so that gives us 7. And then that leaves for us, for other types, 2 and 8. Because again, outside the 2 lines, opposite sides of the transversal, but not adjacent. And then the last type of angle pair are what we call corresponding angles. They're on the same side of the transversal and same side of the lines Q and R. I don't like that definition. I think it's hard to explain what's going on with them. So here's the way to look at it. Okay. Whenever the transversal cuts through the 2 lines, it creates 2 groups of 4. And let's see here what color looks good. Let's do light blue. Group of 4 up here, group of 4 down here. In the group of 4, there will be a top left, top right, bottom left, bottom right. Top left, top right, bottom left, bottom right. Okay. Even if you turn this way here, it doesn't matter. This would be top left, top right, bottom left, bottom right, top left, top right, bottom left, bottom right. So it creates these 4 pairs of angles. And what happens is, 4 sets of angles. And what happens is, If you're in the top left up here, your corresponding angle is the one in the top left on the other group of 4. So 1 and 5 correspond because they're in the same corresponding position. Top left, top left. Next pair, 2 and 6. 2 is in the top right, 6 is in the top right. Top right, corresponding position. 3 and 7, bottom right, bottom right. 4 and 8, bottom left, bottom left. Okay. So that's how it works with corresponding angles. And again, if I turn it this way even, top left, top right, bottom left, bottom right. Turn upside down, top left, top right, bottom left, bottom right. So they put themselves in the same groups and same positions. Okay. So it's basically just definition work. Another thing too, and I'm not going to lie to you, when I was in school, we called them same side interior. We did not call them consecutive interior angles. It still bugs me to say consecutive interior. I prefer same side interior because on the same side of the transversal inside the 2 lines. But our book goes with the consecutive interior. So yeah, that's another name to call them. And I sometimes let it slip. So here's your homework on 2A through 2D. Classify them as alternate interior, alternate exterior, corresponding or consecutive interior angles for these 4 angle pair groups. If you got any questions, come in, before school and we'll sort it out. Thanks.